Astronomy is all about stars and their movements in the sky, and today we shall learn something about the movement of stars in the sky. You must recall that sky has been observed by people for a very long time. It was also a practical proposition for them. By looking at the sky and the movement of stars and the position of stars at a certain time, they could guess what time of the year it was. They could, for example, tell when the rains would come and they would have to plow their fields. They could tell when summer would come and they would have to wear lighter clothes. They could also tell when winter would come and they would have to dig out their woolens. So, looking at the night sky was a very practical proposition for those people, and today I am going to introduce you to the exploration in the sky. I shall use a website called www.heavens-above.com. I shall use this website to explain to you the night sky. We have here the night sky for today. Today is 10th July 2006, and this night sky is for the time 10 o'clock tonight. Let me remind you, if you really want to enjoy the exploration of the sky, the best thing to do is to go to a far off place where there is no smoke or dust and the moon is also not very prominent, so that all the stars are very visible. This sky is today at 10 o'clock at Delhi, and let me begin your tour from the pole star. This is the pole star, and how do we locate the pole star? You must have learned in your earlier classes that this prominent constellation called Ursa Major or Saptarishi in our own language is, and these two stars, they point, you can see they point towards the pole star. This pole star is towards the north. Remember that the direction north is fixed always with respect to the pole star. So, this is pole star here and this is direction north, and once you have located north direction, then you can easily see this will be your east on this side, this will be your west on this side, and this will be your south. So, this is the pole star. This is the very prominent constellation in the sky, Ursa Major or Saptarishi, and this one today you can see, if you look at the sky today, this is only a portion of Leo. Let me show you 2 hours earlier and you will see this Leo very clearly. Let me show you 2 hours earlier, say at 8 o'clock in the night today. Here is this Leo, constellation Leo, and not only Leo, you can also see the 2 planets, Mars and Saturn here and Jupiter here, and this is once again the Ursa Major, pole star, north direction. The other prominent things to see in the sky today, in addition to Ursa Major, in addition to Leo and Saturn, Mars and Jupiter, is this star. It's very prominent star, this one Spica, and this star, another bright star here, another bright star here. This is Aldebaran in Leo, and this forms a triangle. Yes, this forms a triangle. So, if you start looking today, you should be looking for these things. All right, let us go tomorrow. Before I go, I want you to note or remember the positions of these constellations, so that you can mark that tomorrow they are not at the same place. Okay, so let us go tomorrow. You can see that this Saturn is about to set. The Ursa Major has shifted slightly. Pole star is of course fixed. If we take a month later, let us see what happens. Month later, say on 10th of August 2006 at 8 o'clock in the night. The pole star is here once again. This is not shifted, this obviously, because this is a fixed position. The Ursa Major has shifted slightly to the west. This again has gone half hidden from us, half set, and part of it is still visible. And these are the three stars, these are two of the three stars I showed, one here and one there, these two bright stars. And Jupiter now is here. So if you see a month later, you would see this is the position of Jupiter near this bright star. Okay, let us see in September, the same September 2006, 10th September 2006 at 8 o'clock in the night. You should be able to see clearly that Cassiopeia and Ursa Major, they have rotated around this pole star. It was here, it has gone there. So you can see that all stars rotate around the pole star. You can see this bright star, but the other one is set. This Jupiter has shifted to the west. So let us see 6 months later. Let us see March 2007. March 2007 and 10th March 2007 at 8 o'clock in the night. You can see the scene is completely changed. I have been telling you that the stars rotate around the pole star, and you can see that the Ursa Major from this side has come back to this side, and Cassiopeia from this side has gone to this side. So you can see the complete rotation of these two constellations around the pole star. Now another prominent constellation in the sky, that is Orion. Orion is this three stars in the middle and two stars here, very prominent stars, and two very prominent stars here. Leo is here. You can see it had set there and it has now come back and risen from the east. Leo is here and Saturn is here. Jupiter is no longer seen. So you can see that sky changes every night, and therefore one can tell, for example, this is now March, and if the constellation Ursa Major is here and Cassiopeia is here, we can say that it is March, it is spring season. And in the summer we saw the position here, the constellation Cassiopeia was here and Ursa Major was here, and so on, it keeps on changing. So the sky is always changing, and the only thing fixed is the pole star. The pole star is always fixed, and all other stars, all other constellations, all other things, they rotate around it. I have told you how to explore the night sky, and now there are more things to be done with the night sky, many more things that need to be told, and we have here now the director of Nehru Planetarium in Delhi, Dr. Ratnashri, who would explain to you further exploration of the sky.
We are standing here at the Sky Theatre of Nehru Planetarium, New Delhi. We are going to use the projection facilities of the planetarium to observe movement of the sun in the sky, its daily, its annual movements, locate some stars in the sky, look at their movements in a given night over a period of few months, years, etc., and then learn to look at these objects in terms of some quantitative coordinates. That's what we are going to do today. We start with observing our surroundings. So we have a look at, we have the panorama of the city of Delhi around us. We start with viewing that.
Rashtrapati Bhavan in the north, Parliament House, Jantar Mantar, Jama Masjid, Lal Killa, India Gate, Supreme Court of India, Purana Killa in the east, Jawaharlal Nehru Stadium, Safdarjung Tomb, India Meteorological Department, IIT Delhi, Qutub Minar in the south, Teen Murti, Ashoka Hotel, embassies, Moria Hotel in the west, Talkatora Stadium, Birla Mandir, back to Rashtrapati Bhavan in the north.
We start with directions. Many of us feel that sun is a very good tool for us to find out directions in the sky. That is not strictly true. It can give us a rough sense of directions. We see the sun rising. From its position, we get a rough idea of where we have the direction towards east. We can use the sun in the daytime to find out exact direction north. Once we have that, we have our direction set east, west, north, south, etc. Once we have these directions marked for ourselves, we can start our observations of the sun. We all have heard that sun rises in the east and sets in the west. We also have a good idea why that happens from the rotation of the earth from west direction to east, and we see sun moving in the sky from east to west, and approximately west, somewhere in the direction west, we would see the sun set in the evening. March evening skies, we have the sun setting in the west, and the sky is filled with a number of stars. If we go outside polluted cities like Delhi or Bombay, we can see a number of stars in the evening sky. The most celebrated object in the evening sky, one which we all hear about from our childhood, is Saptarishi, 7 stars. Our ancients imagined 7 sages in this group of stars. To me it looks like a kite. Those stars forming the body of the kite, and the stars here, the tail of the kite. This is a very useful constellation for us to locate certain objects in the sky. These 2 stars of Saptarishi point towards the pole star. Wherever Saptarishi is in the sky, these 2 stars point out pole star to us. There is one other pointer in the sky, the constellation of Cassiopeia, like a W or an M in the sky. This is like 2 triangles. There is an acute angle triangle and there is an obtuse angle triangle in this W or M. We take the obtuse angle triangle, bisect this angle, and that bisector also points out the pole star to us. Using these 2 pointers, we find out the direction north, and once we have the directions marked for us, we start with a few quantitative idea about objects in the daytime and the nighttime sky. If we want to have an idea of what is their behavior in the night sky, we have to first get a feel for the relative location in the sky. So, the shape, for instance. We have a number of these constellations with which we have to get familiar over time, and once we locate a given object in the night sky, we ask ourselves this question: what is this object doing in the night sky from, let us say, 7 o'clock in the evening to 8 to 9 to 10 and so on. We observe any one star from here, and we also locate some object in the horizon. We have now the panorama of Delhi all around us. We look at one star in the evening sky, and we have our city around us. We observe any object far away in the city skyline, and we can take a divider one end of the divider will be pointing to that object in the evening in the skyline of the city. The divider will be pointing to that object. The other end of the divider will be pointing to the star that we have chosen. Take a steady divider, make sure that the two ends of the divider are pointing to these two objects, then bring the divider to a lighted room, measure the angle between the divider, redo this after an hour, after half an hour and so on, and one can immediately see that this angle is changing. In fact, what we do see is that stars in the evening sky seem to be rising and setting. We can do one more thing. We also measure the relative position of any star with respect to some other star. Let us say we take any star in the sky and measure the angle the star makes with another star in the sky, just as we did it with a terrestrial object in the background. Then within some errors we will find that these angles do not seem to be changing. Try it with different stars and directions towards the horizon and see what is the kind of change that you find for these objects. So that is in fact the reason why we have definitions of constellations. Over hundreds of years our ancients found relative shapes in these objects. For instance, here we have Scorpio, a beautiful scorpion in the sky. That is what our ancients imagined here, and this relative shape has not changed over hundreds of years. As our ancients observed it, we find no change in the relative shape of these objects.
Dr. Ratnashri has told you how to explore the sky. I have also told you how to explore the sky, but you would remember that you can explore the sky only if you know your directions. I told you that you can fix north direction with the help of the pole star, but pole star is not visible in the daytime. So what do? How to get the north south direction in the daytime? Let me tell you, there is a very simple way in which you can do it. Have a stick of about a meter length and place it vertically in the ground, and then look at the shadow of this stick, and with the help of these shadows you can find out the exact north south direction without the help of pole star, because there is no pole star in the daytime. So what you do is, there are two ways. You look at the shadow and mark the position of the minimum shadow during the daytime, and then if you join this with the point where the stick is fixed, then this direction is the exact north south direction. The other way is, you draw a circle round this stick with the stick position as the center, and let the shadow touch this circle in the morning and the evening, and you join these together at the point where the stick is fixed and bisect this angle, and the bisector of this angle then is the direction of north south. And I would advise you to carry out this activity. This is a very interesting activity, and you carry out this activity and mark the north south direction in the compound of your home or school or wherever you are, and you can use this then to trace objects, prominent stars, constellations, or whatever else you want to do in the sky. Now Dr. Ratnashri will tell you in greater detail how to fix these directions with the help of the shadows.
We want to know the directions from our observation point. We can use the pole star to find the directions, but on the ground if you want to know directions north, south, east, west, so that we can get to know altitude and azimuth of objects, this is one simple thing that we can do. We have a straight gnomon, a cricket wicket will do. We put it perpendicular on the ground, make sure that it is perpendicular, and we make sure that the ground around it is level, and we just need to look at the shadow of this stick. This is our gnomon, At equal intervals of time, we mark the end of the shadow of the stick and we measure the length from the center to the edge of the shadow. We will find that the length is decreasing as the day progresses. At midday, the length will be the shortest. So, if we measure every 5 minutes, 10 minutes, we will find when we have the shortest shadow with a least count of those 5 minutes or 10 minutes, and the direction from the center of our gnomon at the ground, the center point, towards the shortest shadow of the stick is the direction north. Now, when we are actually measuring these points around solar noon, our accuracy will depend on how fine a point we can make and the time that we can make it at around the solar noon time. If we do not know a priori when is the solar noon, we might not be able to get that much of accuracy around that time. One thing we can do is look at the end of the shadow sometime in the morning, and using this length as the radius, we draw a circle around our gnomon with that radius. We have drawn a few circles from the morning shadows with radii equal to the length of the shadow, and in the afternoon the sun cuts these circles at exactly one given time. So, in some cases we have here marked the point where the sun shadow has cut this circle. We will draw this chord from this point to this point. We bisect this chord of any given circle, and from that point we join to the center of our point where we have kept the gnomon. This then gives us the direction towards north.
Dr. Ratnashri has been explaining to you the way how we can find out the north-south direction. I strongly advise you to carry out this activity yourself. This is a very interesting activity, and you can find out with the help of this simple activity the north-south direction quite easily. And once you have found this direction, then it would help you to trace prominent objects in the night sky, because you need these directions to explore the night sky. Now, Dr. Ratnashri would use the facilities of Nehru Planetarium and would show you the computer simulation of some of the things that you would see in the night sky.
We are looking in the direction north, northeast direction. We have the Saptarishi or the Big Dipper. The 7 stars of the Big Dipper here can be seen like a kite soaring in the sky. This is the body of the kite and the tail of the kite. These 2 stars of Saptarishi point out the pole star to us. That's the pole star. These are the pointers to the pole star. When we do not find Saptarishi in the sky, we can also use the constellation of Cassiopeia. This is the constellation of Cassiopeia, an M or sometimes a W in the sky, and it consists of 2 triangles. This is an acute angle triangle here and an obtuse angle triangle here. We take the obtuse angle triangle of Cassiopeia, bisect it, take the bisector, and the bisector also points to the pole star. We then reach the pole star. So, this is a way we can find the pole star in the sky. Shows us the direction towards north. The interesting thing being that if we observe these stars through the night, let us observe the stars of the Saptarishi as the night proceeds, rising from the east and moving towards the west. These 2 stars of Saptarishi are always pointing to the pole star, no matter where Saptarishi is. Similarly, here the Cassiopeia has set, it is now rising, as Cassiopeia rises, the bisector of the obtuse angle triangle always points out the pole star. So these are the circumpolar stars. They are rotating around the pole star as all stars here rise and set. And pole star remains stationary at this point. This is the diurnal movement of the stars. Rising in the east, here we have the constellation of Orion, the constellation of Gemini, these two twin stars, Castor and Pollux, and we find all these stars rising in the east and setting towards the west. We have here the constellation of Scorpio. Let's observe Scorpio from the horizon. We move towards the south. Our view now is towards the south. When we view towards the south, here we see this S-shaped group of stars, the constellation of Scorpio. Rising in the southeast, this constellation moves towards the southwest. As the constellation of Scorpio sets, we find that towards the east we have the constellation of Orion rising. All these stars and the planets, the sun, all of them, we find that they are executing this east to west movement, while pole star remains stationary in the sky. These define the daily movement of the stars. Now if you look at any one group of stars, we see this to be the shape of Orion, or we see a shape of a lion was imagined in this group of stars, and our ancestors imagined a number of constellations in the sky, forming many interesting groups. Amongst all of these, there are some which are treated as special. These are the zodiacal constellations. Here, the line here that we see is the path of the sun in the sky, and grouped around it we have the zodiac constellations. Alright. These are the zodiac constellations: Taurus, Gemini, Cancer, Leo, Virgo, and so on. If we observe any given object in the sky, any constellation in the sky, we find that its shape remains, that's the shape of the Saptarishi, today, tomorrow, a month later, a year later, 10 years later, we observe it, we find that the shape has not changed. So also the constellations of the zodiac. But if we keep observing the constellation of the zodiac every day, we will find that in the background of these there are some objects whose positions change with time. These are the planets. That's Jupiter. The moon moves the fastest in that group. The fast movement there is that of the moon. Here is Saturn, a slow mover in this belt. Jupiter here, and the telescopic planets, Uranus there. Here is Mars. We find the movement of all the solar system objects to be along this east-west belt of constellations, which is the zodiac. If we look at the star, pole star, we find that over days, over hours, if we observe it, we find it is remaining stationary in its location while all other stars are revolving around it. We observe that all stars seem to be revolving around pole star as time progresses. If we move forward in days, we will see that planets have a relative motion with respect to the zodiac. we find change in the position of rising time, setting time, position of planets against the background of stars. We find all these changing, but pole star still remains stationary in its location.
All this time we have been telling you about the exploration of the night sky. Why is it important? First, it is very interesting. If you start using the night sky to explore stars, you would get so much interested that every day you would be prompted to look at the sky. And the best place, as I told you, of course, is the place where there is not much smoke or dust, and when there are no clouds, and when there is no moon. We have done two major things today. One, we have seen that night sky changes all the time, and I have told you how the night sky would appear today. If you look at tomorrow, how it would appear. If you look a month later or 2 months later or 6 months later, how it would appear. This is what we have done, one thing. The second thing we have done is to find out the north direction. Why is north direction important? Because you can trace or track stars in the sky or other objects in the sky which are very prominent only when you know your directions. So, it is very important that you learn how to find out the true north south direction. These are the two things that you have done, and I strongly advise you to carry out the activities we have told you, so that you can benefit from whatever we have told you today.